Okay guys, so this is lesson number 2, part B. We're going to be talking about polygons now, so a little bit more specific in our shapes. So a regular polygon, first of all, is a polygon that has sides that are all the same length. So if you look at some of these examples, equilateral triangle, square, those are pretty obvious ones that we've seen before. We know that those all have the same exact sides. Other examples, regular pentagon, hexagon, blah, blah, blah. So all those different ones, again, we know that all the side lengths are going to be exactly the same. We also know that the angles are going to be the same. So what that means is this angle is equal to this angle is equal to this angle. This one is the same as this one, and this one. This angle is the same as this. You guys get the drill. So again, all of our angles and all of our sides are going to be exactly the same. Now, obviously we have those kind of relationships. It makes it a little bit easier for us to solve for missing angles and sides. So if we look at the bottom here, it's saying a convex polygon. Again, this is just some definitions that you will need to know. It's saying a polygon in which each interior angle, so remember interior means inside, they measure less than 180 degrees. So we know that they have to be kind of small angles. If we take a look at an example, again, just kind of between a convex polygon and a concave polygon, which is basically a non-convex, something that you guys can notice over here, I just put, notice that all the line segments joining any 2 points are inside the polygon. So what I mean by that is, let's just take one of the points and I'm going to connect it to everything. Here, same thing. All these lines lie inside the shape. Whereas if I do over here, okay, well, yeah, that's okay, that's okay, that's okay. This one's all right. But then but if I take this one here? That's okay. Uh-oh, that's not okay. That's not okay. And that's not okay. So this one we know is concave or non-convex because basically our line segments are not inside the polygon. So just a bit of definition for you guys. If we look, okay, how do we apply this? What's the point of this? Well, again, we're looking at these convex shapes, and it's saying the sum of the measures of the interior angles of any n-sided convex polygon is. So it sounds kind of wordy and crazy, but it's saying the sum of the measures of the interior angles. So if we add all of the angles on the inside of the shape, if we add all of them up, we have a formula here. The sum of all of these angles has to be equal to 180 degrees times n minus 2. And n is the number of sides that we have. So n is the number of sides. So let's look at an example so this makes a bit more sense. Example number 4, find the sum of the interior angles for the following polygon. So what is it asking? It's saying, okay, well, this and this and this and this, we know because it's a polygon, it has to be, all of these are exactly the same. And it's asking for the sum. So I want this plus this, plus this, plus this, so on and so on and so on. Well, luckily we have this formula up here. I know that the sum of all the angles is equal to 180 degrees times n minus 2, where again n is the number of sides. So we're just going to count up the number of sides here so that we can complete this formula. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we know in this case n is equal to 10. So that tells us the sum is going to be equal to 180 times 10 minus 2. Well, that's 180 times 8. 180 times 8 gives us 1,440 degrees. If we look at B, again, I'm looking for the sum. So this plus this plus this plus this plus this plus this. So again, our sum is equal to 180 times n minus 2. Well, the first thing we need to solve for is n. Count up your sides. 1, 2, 3, 4, 5, 6. So I know n equals 6. So that tells me the sum of all of our inside angles must be equal to 180 times 6 minus 2, which is obviously 180 times 4, which is going to give us 760 degrees. Let's look at the next example. The angle sum of a polygon is 2,160 degrees. Determine the number of the sides of the polygon. So if I know the sum is equal to 180 times n minus 2, I know if my sum is 2,160 degrees, that must be equal to 180 times n minus 2. So in this case, we need to solve for the number of sides, which in this case obviously is n. So we need to actually work backwards here. So remember, what we're kind of doing is like a reverse BEDMAS. So the first thing that we want to do would be addition and subtraction, but unfortunately our addition and subtraction is in our bracket, which is one of the last things that we need to deal with. So I'm timesing by 180. What we're going to need to do is the opposite. We're going to need to divide by 180. And that's going to cancel these guys right out. But remember, what I do to one side, I must do to the other side. So we've got 2,160 divided by 180 gives us 12. And that's going to be equal to n minus 2. Now, in order to solve for n, obviously, last step, add 2, add 2. So our 14 is equal to n. So what does that mean? We have 14 sides on our polygon. Let's look at another one, example 6. The angle sum of a polygon is 1440. Determine the measure of one angle. This is kind of similar to the question that we just did, again, because we're given our sum. So remember, our formula is sum is equal to 180 times n minus 2. So we know that our sum is going to be 1440 is equal to 180 times n minus 2. So what we can do is obviously solve for n with the information that we're given, and then let's talk about how to find one angle. So this is just like what we did before. We're going to divide by 180, divide by 180. Those are going to cancel. We're going to be left with 8 is equal to n minus 2. Add 2, add 2. 10 is equal to n. So remember, what does that mean? We've got 10 sides. Well, if you imagine, I'm not going to even attempt to draw this shape, but if you imagine this polygon that has 10 sides on it, and we know that all of those angles, when I add them together, I get 1440. So I get 1440. So something plus something plus something plus something, blah, 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 is equal to 1440. How would I solve for one angle? Well, all you're going to have to do is take that total 1440 and divide it by 10 sides. And that's going to give you one angle. So obviously that's going to give us 144 degrees. Now this is actually something, guys, that's quite significant, because really, what's the point of knowing the sum of all the angles? We really want to know what each angle is, and that's going to help us solve some of the shapes, and you'll see that in the next example. So let's summarize this. This is, again, kind of important, so be sure to write this down. To find the measure of one angle, we know that our angle is going to be equal to our 180 times n minus 2, so again, the sum of all the angles, divided by the number of sides. And that's going to give us, again, the measure of one angle, which is a little bit more useful to us than looking at all the sums. Our next example is something more similar to what you guys are going to be seeing in your assignment. And I'm just going to talk about things. This kind of is a little bit of a difficult question because we're trying to find all these missing angles. So right now you have to remember all of the information that we've been given, you need to apply. So way back in lesson 1 when we talked about parallel lines, which you can see that we have here, parallel lines. We can go back to, you know, that Z rule and the F rule and the C rule even. Remember that C one that we talked about where we have supplementary angles. So all of those you need to be aware of. As well, now we've got a triangle, which again, you guys know a little bit about triangles. All the angles have to add up to 180. And you also need to know that now we've got basically a polygon, and we've got interior angles here. So remember our formula, how to find one angle. Well, if you take a look at A, there's no numbers that are given here. So we're actually going to need to solve for A first, because that's the only thing that we can solve for. I can't look for B, C, or D because we're not given enough information. However, A, remember, is one angle in our polygon. So let's count up our number of sides. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we know that n is equal to 9. Remember how to find one angle. It's 180 times n minus 2 divided by n. So that's going to give us 180 times 9 minus 2, all divided by 9. 180 times 7 divided by 9 is going to give us 140 degrees. So in A, we've got 140 degrees. Now we've got B, C, and D left over. Now I'm going to turn our attention to this B down here, so this triangle. Now what we need to recognize is that we have actually got a little bit of information about this angle right here. We actually solved for it already. That's 140, because that's one of our interior angles. Now, according to this triangle, I know all the angles have to add up to 180, but guys, notice this is kind of a special triangle. This side and this side are the same because this is a regular polygon. And if I kind of redraw it over here, if I have a triangle with the same side lengths, this is called isosceles. Okay? And with isosceles triangle, not only do we have the same side length, we also have the same interior angle, which is really, really, really useful for us when we're trying to solve for angles. If this is 140 degrees, and I'm looking for these guys right here, I know that angle B, which is one of them, would have to be 180 minus 140 degrees, so that's going to give us 40 degrees. But then that 40 degrees has to be split up in between this guy and this guy. So what we're going to do is divide it by 2. And that's going to give us 20 degrees for B. So I can label that right in there. Okay? Now, guys, we can take a look at some other information here. What we're going to need to identify is actually some angles that we don't even really necessarily need to find. I'm just going to erase this stuff here. Okay. So again, I know that that's 140 degrees, and I know that this is 20 degrees. Now, this angle right here, okay, if you guys kind of take a look, remember that C rule that I talked about before? This C right here. Now remember, this angle and this angle, according to that C rule, are supplementary. Remember that that means that they add up to 180 degrees. Well, this angle we're not asked to find, but it's definitely going to help us solve for C. So let's figure this one out. Remember, guys, I know that my interior angles, so all my interior angles, has to equal 140 degrees. So this guy right here is going to be 140 minus 20, and that's going to give us 120 degrees. So if I know that that's 120 degrees, and I know that this angle plus this angle has to be equal to 180, then we know C will need to be 180 minus 120, which is going to give us 60 degrees. Now our last angle, which is angle D, I've got this, I've got this, and I've got this. So all of these angles all together, hopefully you guys remember, all the angles have to add up to 140 degrees. So if I look at this one, obviously we've got that one. This one, I didn't write it down, but remember we know it already because it's part of that isosceles triangle. That is 20 degrees. Well, if all of them have to add up to 140, then angle D must be 140 minus 60 minus 20. And that's going to give us 60 degrees. So that's going to be this guy right here. Okay? So this one's a little bit tricky. We're looking for parallel lines, we're looking for the sum of angles, we're looking at isosceles triangles. You guys will have a question like this one. So if you want to go over it, if something doesn't make sense, make sure, please come to the help desk, and one of us teachers can definitely go through this again with you. The last example is kind of a cool one. This is what is neat about the 20-2 program. 20-2 is real world, guys. So the majority of the jobs out there only require a -2 and not the -1. And a lot of the jobs out there are hands-on jobs. They're things that you actually can create and do, which is like this example. It's saying a floor tiler designs custom floors using tiles in the shape of regular polygons. Can the tiler use congruent, meaning the same, regular octagons and congruent squares to tile a floor if they have the same length? Now in class, what I do is I give students the opportunity to just kind of play around with this and try and connect the pieces, because the whole idea is, imagine a tiler comes in and they are going to tile a rectangle area, maybe your foyer or whatever, okay, or your living room or something, you want to tile it. Well, what they have to do is basically put this shape and this shape together so that there are no gaps whatsoever, and they're going to tile this entire floor. So those of you that are really visual, you might recognize automatically, ooh, cool, if I put a square here, and then I put an octagon here. Now, excuse my drawing because it's terrible. There. And then if I, keep going, oh, wait, then I can have an octagon down here. And then I can have a square here, and then I can have an octagon here. Okay, you guys get the drift? So you can kind of piece this together. Now, some of you are going to see that right away, and some of you, like me, are going to take a long time to actually be able to put those together because maybe you're not so visual. Another way of doing this, so again, the question is saying, can the tiler use these if they have the same length? Yes. And this would be good for an answer. You just showing me what it would actually look like. Now, what's the reasoning behind this? You think, okay, well, this is a math class. What's the math behind this? Well, recognize, guys, that all of the angles, if they have to all stick together with no gaps whatsoever, all of these angles, this plus this plus this, would have to equal 360 degrees, so that that doesn't have any gaps. So we can check all of the interior angles and actually prove that this is going to work. So first of all, let's look at the octagon and let's see what the interior angle is going to be there. So it's going to be 180 times. Now remember, an octagon has 8 sides. 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 2 divided by 8, because remember, we're looking for one of the angles. So when I do that, I'm going to get 135 degrees. So if I just draw it over here, I know that this is going to be 135 degrees. Obviously, this as well is going to be 135 degrees because that's the octagon. Now, you guys all know this angle right here on the square has to be 90 degrees. Well, let's add all of those up, and hopefully we get 360. So 135 plus 135 plus 90. If you guys do that on your calculators with me, you'll see that we actually do get 360 degrees. So that's just kind of the math behind that as to why it actually does work. Now, this is part B, which is the last part of lesson 2. Please remember, you should now be looking at your textbook, page 90 and 99, to practice what we've just talked about. And that will help you, once you're done that, to finish the assignment questions. Again, come to the help desk if you have any questions.